It's recording. All right. So, what would the? Let's see what the Google Hangout says to do today. All right. Says begin by sharing your answers and techniques to the preparation assignment. More than one method for solving is used. Consider whether both or not both are correct. Be sure to spend time teaching one another to ensure each team member is confident in solving the problems. So let's take a look at the preparation, I guess. Did everybody understand the preparation?
Yeah, I understood it for the most part. This week doesn't seem too difficult.
Yeah.
Yeah.
All right.
Yeah, it's pretty self-explanatory.
Mm-hmm. Yeah, it is. So everybody understood it, and we can move on.
Yep, that's a fair statement.
All right. So number 2, another technique used in solving and also in calculus, the idea of use substitution. Use substitution can be used to make a more complicated problem look less complicated. Consider the following problem and how the use substitution is used to solve the equation. And it shows the equation. Do y'all want me to screen share so you can see it? Or
Yes.
all right, I will do that. And hopefully, it doesn't freak out. All right. Let's go with. Oh, I can just screen share that. Oh, where am I? Oh boy, this is interesting. I'm trying to look at the screen and figure it out. All right. So can y'all see that?
I see like a black box.
All right. Let me figure this out again. All right.
There we go.
All right. Let's go. Where was it? There we go. Week 4. Shoot that down. Oh, that's horrifying looking. All right. There we go.
Oh, sweet. Screenception.
Yeah. Does that work? Sort of. Okay. Let me minimize this so it's not screenception. Is that better?
Perfect.
I mean, I can't see y'all, but y'all can see the stuff, so it's okay. All right. So we look at this problem. So I make it easier by substituting in the u for the equation. All right. This doesn't look hard at all. It's simple, I guess.
Yeah, I think it's just like a way to make that 5x minus 1 be just less complicated.
All right.
So wait, the original problem is 1 over 5x minus 1 plus 1 over 5x minus 1 squared.
Yep.
Mm-hmm.
Replacing 5x minus 1 with u.
Yeah.
So it's just 1 over u plus 1 over u squared.
Yeah, equals 12.
12, yeah.
And so the answer would be 5x minus 1 plus 1 equals 12 times 5x minus 1 squared. Or do you never factor it back out?
Oh, that makes sense. So I think you just, from what it looks like here, you've got u plus 1 equals 12u squared, and then you make that a quadratic equation, or not a quadratic, yeah, it's a quadratic equation.
Yeah, so that's a quadratic equation.
Polynomial, yeah. And then you solve for
12
for
u or x.
Right. Right. So that becomes.
All right, guys, let me turn that off real quick.
Yeah, that makes sense. Wait, you do have to do a back substitution. That's what it says.
Yeah. Well, when you simplify the entire equation, you'll get u plus 1 minus 12u squared equals 0. And then you just plug in for your quadratic equations. So your a would be negative 12, b would be 1, and c would be 1. And then once you start simplifying and doing all the math there, it'll equal out into those fractions that you'll get. So.
All right. So you don't have to resubstitute your 5x minus 1 in there? I mean, you could, but you don't have to.
Yeah.
Yeah.
So you can just. All right, that makes sense. Yeah. And then extension problems. So there's only 2 of them. Okay.
Well, number 1 has
right multiple parts, but
yeah.
In the whole aspect of things, yeah. Yeah. Okay.
Right back.
Well, you know what? I was actually just looking at this. So once you get your fractions with the u, you then plug in those 2 fractions back in, and that's how they get x. So you plug in what you get out of your quadratic equation, which it looks like it's negative 1/4 and 1/3. And so then you plug it in and you go 5 times negative 1/4 minus 1.
All right, that makes sense. And then let's see. So do we just want to take a crack at these extension problems then?
Sure.
Sounds good to me.
As
long as it doesn't take as long as last time.
Right, that's what I'm saying. I got work at 1.
At 1, I hope we're done before 1.
Yeah, I'm sure we will. I'm just.
Well, I have work at noon, and I didn't even say anything.
Oh.
I was already doing some of the problems just to speed the process up, and bullet number 3 is going to be a pain in the butt with that radical. So just warning you all.
Okay. So do we want to have someone else screen share? So
I can screen share that because I don't let's be doing it.
That'd be good. And then we can just do it separately. And
so, Chris, this is the second time you're taking this class?
Yeah.
I like appreciate that fact so much. Like, and it was, I think the longest hangout we've had was
what am I doing? There we go. Darn
the
it.
longest hangout that we had was when we had to talk about questions that we had troubles with.
Mm-hmm.
And you were the one that brought up a question, and you're like the one who knows the most about this class. So we were all just like guessing.
There we go.
Right.
Oh, there it is. Yeah. Desktop and start screen share. Trippy again. Okay. So that's number 1 right there.
All right.
So you could take this whole thing and add the 12 to this side right here. And factoring this comes out to this. You set that to 0, it gets you 1. Set that to 0, it gets you 3. And setting that to 0 gets you a negative radical, which is imaginary. But that's the idea.
What did you substitute for it?
What do you mean substitute for it?
Are we supposed to substitute, like do the substitution method on all of them, or just try to solve them?
If it makes it easier, then use it. But if not, if we can just solve it that way.
So are we supposed to substitute anything specific? Because I mean, for number 1, it doesn't look like subbing would do anything.
No, it wouldn't.
Number 2 doesn't look like substituting would do anything either.
No, because you can't. Yeah.
Mm-hmm.
Same deal. Because this factor turns into this. And you have to subtract these numbers and then get them to radicals, so it'll be negative square roots, which is imaginary.
And then for number 3, is number 3 easier to substitute u for 2x plus 1? Or you can't because there's 2 parentheses?
No, yeah, if these were the same, then I think you could do that. Because like another problem was 5x minus 1, they're both the same. But
for 5, we could do u substitution if we want to. Because that one, it would make sense because you've got the x squared minus x inside the parentheses on both. Make it easier to work with.
oh yeah, so for this first thing, you're squaring this whole thing to get rid of those radicals. So it's like a plus b squared. So there's your a plus 2b. And there's your b, and then there's the 2 of them, 2ab right there, equals that squared, which is just 1. So that's where this mumbo jumbo comes from.
So wait, why do you still have them in the radicals then if you squared them in the first step?
Oh, this got rid of the radical, and this got rid of the radical. Or this right here, just kidding. That right there. But you still have to combine them together to get this. So it's 2ab.
I don't think I understand what you're saying with that.
So here's A,
Mm-hmm.
and that's B, and this is 2 because 2AB. So it's just this and this combined, which is this and this.
Why did you have to combine them?
I'm not sure.
Because you could just square both sides and it would just end up 2x plus 1 minus x equals 1.
Yeah, that's what I was thinking too.
Yeah.
If you what I would do is I would try and subtract the square root of x over and then square both sides.
That probably would have been a better idea.
Then that would get rid of both your squares. So I'd get square root of 2x plus 1 squared equals 1 plus the square root of x squared, and I'd get rid of both your squares, right?
That's a better idea. And then let's get rid of that. All right, and then we want to square this side to get rid of that too.
Yeah.
Square this again.
You have to square it again. I thought if you square rooted or if you squared both sides, you would just get rid of the radical on both sides as well.
I don't think so. I'm not sure. I don't think so. That doesn't sound correct to me for some reason. That's just me.
Isn't it?
It would be
Yeah,
2x.
because it would cancel out if you square a square root, it cancels the square root out.
Oh, so you're just saying it would be 1 plus x?
Yeah.
Yeah.
Oh, sorry.
Mm-hmm.
Oh. And you can subtract the 1 over here.
Yeah.
Maybe 2x equals x.
But then I don't know what you'd do from that point.
Subtract the x and then x equals 0. I mean,
X does equal 0. True. But then where? Let me check the answer key.
Yeah. Where does that 2 go?
Well, when you subtract the x, you have to imagine there's one x, so it'd just be x. So it'd be x equals 0.
Okay, the answer key does confirm that there indeed should be a 4 right here. So
Maybe okay. So when you in the first step, when you have 2x plus 1, 1 plus x, before we do that, I think it should be square root 2x plus 1 plus the square root of x, and then you have to square root both sides, and so it would be then it would just be normal 2x plus 1, and then parentheses 1 plus the square root of x, and parentheses squared, because you'd have to square the whole thing, and then you'd have to factor it out, right?
to repeat that again, sorry.
So like the first step, so you know how we would have square root 2x plus 1 equals 1 plus the square root of x?
Yeah.
And then we would square both sides. So that would be parentheses radical 2x plus 1 equals 1, or yeah, so
parentheses 1 plus x, or square root of x squared. Right.
let me just write it out, and then I'll just show you guys on my paper.
That sounds good to me.
I see what you're saying.
What did it all look like this? Like you factor it out instead of getting rid of the radical.
Oh, just hold it right there. Oh, hold it right there again.
Oh, sorry.
So it'd be 1 plus radical x. Okay, you can put it down now because it's the same thing.
Okay. Does that make sense at all? Like where I got that from?
Yeah.
Oh, yeah, that makes sense.
Because you square the one side, but you have to square the other side not individually, but together.
Yeah.
Makes sense, yeah.
Okay. So
And then factoring it out even more would end up getting rid of the radical anyways, because you would have to do square root of x times the square root of x.
yeah, so that would get rid of that.
You'd still have 2 square root x in that.
There's 1 plus 2 square root of x, right?
Mm-hmm.
Plus x squared.
No, it's just x.
Yeah, because right.
Yeah.
You're right. And then we can get rid of the 1 because on both sides, 1 minus 1.
Right.
2x equals
Equals
2.
square root x plus x.
Okay.
It still doesn't make any sense because we don't have any numbers to deal with.
To get that 4 right there, yeah.
Could you do the square root of the 2 times square root of x and square that whole thing, which would get you 4x? Would that make sense? Because if you square the whole 2 square root of x, then your 2 would be squared, which would get you 4, and then your square root would get rid of your then it'd just be x.
You'd have to subtract an x from the right side to get it to the left. And 2x minus x is
Equals
1x.
4x. Yeah.
4x squared, correct?
Yeah, you're right. Because the square.
I mean, 4
No.
works with the answer.
No, that's not 4x squared. It's just 4x.
Yeah, it's just 4x because the square gets rid of
square
that.
root x, so your x wouldn't be squared after that.
Yeah.
Well, with that answer, 4 doesn't work.
Well, I know. So I'm wondering if the left side if we miss something on the left side to where it would just be to where we could get it to maybe be like x squared equals 4x. Maybe I'm not sure. I'm trying to figure out how to get that though. Maybe could we expand the square root of 2x plus 1, kind of like we did on the left-hand side? Would that change anything?
Try it.
Oh, x squared plus 4x plus 1.
Layout. Orientation, landscape. There we go.
Well, so it's square root 2x plus 1 squared. Right.
Square root. Wait a minute.
If we're starting over, it's the square root 2x plus 1 squared.
Oh, yeah. Well, this will be this.
2.
X squared plus that'd be 2 times 2x 4x plus 1.
Mm-hmm. So wouldn't that be 4x squared plus 4x plus 1?
Squared for 4x. Oh, like that? Yeah, you're right.
Yeah.
You're right. You're right.
And then add a plus sign after that.
Right, you're right.
Just so we can keep it making sense.
There we go. A bit of that.
Equals 1 plus
Why did we square that?
This?
That would be
No.
square root though.
Like,
Because at the beginning it's square root 2x plus 1 if we square that. Then
I'm
it's
just
the
wondering,
square root of
in the answer key, it has 0, 4, but there's no, like, there's no solving it in the answer key.
Mm-hmm.
Mm-hmm.
Let me try this again. X. Actually, no. I know a website that solves these equations. So let me check that out real quick. They have to say. Here. I'll try another one, I guess.
We'll just take off one dot and then just take off the
Just the
first
one
number.
dot parenthesis.
Yeah.
There it is right there. There it is. So we had square root of 2x plus 1 minus radical x equals to 1. And we hit go. And then D says right here there's supposed to be 4 and 0 at the top. And here we'll give you the steps. Can you all see that?
Yep.
Yep.
So let's see. Okay, so yes, we're supposed to add the square root of x to both sides.
We did that right.
We're supposed to square both sides. Wow.
So we had it right at one point. Then,
Yeah, we
right?
had it right.
Yeah.
What the? Stop seeing this. Okay, there we go. That's annoying. So where did we mess up? That's the question.
So they expanded right there. They expanded the 1 plus square root of x. And that's where we kind of messed up, I'm thinking. Which got them as the 1 plus 2 square root of x plus x, because they expanded it instead of just taking away the square root.
Oh. So we messed up right from the start.
I mean, we earlier we did 1 plus square root x and square that and got 1 plus 2 square root x plus x. But then we thought that was wrong and went back. Well,
Oh, so it's just 2x plus 1 right here.
Yeah, it's just 2x plus 1 equals 1 plus 2 square root of x plus something else.
Expand and yeah.
Yeah, so their total equations of 2x plus 1 equals 1 plus 2 square root of x plus x.
So we had it right.
mm-hmm.
Plus x, right?
Mm-hmm.
Yeah.
Yeah, so square this and expand this. Square and expand it. Yep. Got it.
But why would you expand that rather than just squaring it and taking away the square root?
Well,
Yeah, you don't expand the left side.
Well, yeah, that's what I'm saying.
Alright.
why does this not tell you to? Let's see. We know what that is. We know what that is. Okay. Subtract
Yeah.
1x from both sides. Okay. That makes sense. Get rid of both. Yeah, you get rid of both of these.
Oh.
Okay. I see where we messed up.
Subtract 1x from both sides. Okay. 1x. Where the heck is 1x? Oh, 1 plus x. Still no, I don't know where that went.
The 1 plus x it's just with your rule on the right hand side. If you go back to your other page, if you do like terms, they just have 1 plus x plus 2 the square root of x. And so they're saying just to subtract that 1 plus x over the other side.
Minus 1 plus x, and we can get rid of this. And get rid of that.
So that makes x equal to square root x, basically. It's 2x minus x, or no.
Yeah.
Yeah.
2x minus x, yeah.
Equals x.
But how'd they get x squared? Oh, because they squared both sides to get rid of the square root on that one.
Oh, yeah. Wait a minute. This is just x squared. How's this just x squared?
That's what I mean. Is what you do is you do 2x minus x, which just gets you the x equal. So right now you should have x equals, the 2 square root of x. Because once you
yeah.
addition, and then you square both sides to get rid of that square root of x on the right hand side, which is how they got to x squared.
So x squared. Wait a minute.
So, yeah, then they have to
X-
square both sides, square both sides again.
Gotcha. Equals, and it was just 4x.
We need to
That makes
divide by
sense.
4x and get 4.
Yeah.
Hey, look, we did it.
Yeah. Woohoo. Okay. We did it.
That sucked.
Yeah, that was going to be the tough one. So, anyway.
Oh.
Okay, so number 3. Number 4, I was just working on that. We could all do it now. That's as far as I got.
Alright, so we can put both sides to the power of negative 5 over 2. Or I guess square root both sides.
So let's do this. X minus 2. And the way to get rid of a fraction exponent is to
Multiply it by the reciprocal.
multiply it by the reciprocal. Exactly.
Alright.
So that to get rid of that, you have to raise 32 to the power of
2 over 5.
Negative 2/5.
negative 2/5, exactly, to get rid of that.
Well, isn't the reciprocal of negative 5 over 2 just 2 over 5? I think the negative goes away too, because the first is a negative and the second is a positive.
Yeah.
That's true.
I think that would make sense. Yeah, that makes sense.
Because it's like basically that's just the opposite of the slope. That's the way that I remember it. So like if you have one that's negative, the reciprocal has to be positive.
Yeah.
Mm-hmm.
Yeah, excuse me. Okay. And then
So x minus 2 equals 4 is what it comes down to.
equals 4. It equals 4. Okay.
Yep.
We'll believe you.
X minus 2 equals to 4. And then that would mean that x equals 2.
Yeah.
X equals, nope, 6.
X equals 2. 6, yeah.
Because it's negative, so you add it over. So x equals 6.
Yeah.
Let's just check to make sure that that's, in fact, the answer for number 4.
And it's not. What the heck?
What? Okay, so I checked that website.
You have to when you multiply by that fraction and you do it, you have to put the x minus 2 into a fraction as well. So it'd be 1 over x minus 2 times 5/2.
Wait, hold it. What did you say?
When you multiply it by an exponent and you're trying to get rid of your exponent, you have to put, so you do 1 over 2, and then you times the x minus 2 by 5/2.
But that got rid of the negative 5 over 2. So
yeah, but so right now you 1 over x minus 2, and then you're multiplying the x minus 2 by 5/2.
So we're multiplying this by 5/2. Now, what do you say to do over here?
Because you have to, when you do multiplying it by a, 5/2, you have to do that 5/2. You have to make the entire thing into a fraction. So it'd be 1 over x minus 2 times 5/2. Does that make sense? So you, instead of just being x minus 2, it'd be 1 over x minus 2. So you'd have to make x minus 2 into a fraction.
1 over x minus 2.
Yeah,
times
and then you
5/2.
multiply that by 5/2.
Hey, can you put another set of parentheses around the x minus 2? Because the way it's written, it just looks like 1 over x minus 2. Thanks.
Sure. 1 over x minus 2 times 5/2.
Is it going to be positive, or are we multiplying it by negative 5/2?
I'm pretty sure, like you said, it's positive. That way you get rid of it.
So, but then wouldn't it just be 2 over 5?
I'm not sure.
So, Chris, what'd you say when you said you entered it into that site?
Oh, that site? That site claims that this should be a negative. That's what it claimed. I don't know.
It claims that what should be a negative?
This 2/5 should in fact remain a negative. And that would make x minus 2 equals a 4th. Because if you raise it to a power.
Mm-hmm.
And then if you add the 2 to both sides, x equals 2.25 or 9/4.
That makes sense.
That's the way they claim to do it. So let me see about this. So that would be x minus 2 equals 32 to the... So it's still negative, but it's 2/5. That's the only difference. And then, yeah, x equals 9/4.
Mm-hmm.
Well, hey, if that's what it says, let's go with it.
Yeah. Works for me. That's really weird, though. Yeah, because when you do the reciprocal, you get rid of that negative, but I guess not for this. What the... What is that in real life, actually? X squared. Okay, that's supposed to be a squared right there. So I guess we'll do number 5 now, or part 5.
Mm-hmm. So we could replace the x squared minus x with u if you want to.
Oh,
Let
yo,
you
that's
substitution.
not a bad idea. That's not a bad idea.
So it's just u minus 18u equals negative 72.
Will be u squared
Right.
Well, it'd be u squared.
minus 18 times u
18u.
equals negative 72.
And then you could just add 72 to both sides, and then we have square.
Yep, we do. It'll be u squared minus 18u equals negative 72. Yep, equals. What?
You can just do plus 72.
Yeah.
Yep.
And then the two numbers you got are -6 and -12. To multiply together to get
72.
72, and to add together to get -18.
So it'd be, you said u, what did you say with the two numbers?
6
-12 and -6.
Huh.
And then we just replace x squared minus x with
Yeah,
u. We get
x squared
minus 12.
minus x minus 12.
Which is it the opposite? So it'd be 12 because doesn't u have to equal 0
No, so
in order for those numbers to
in order to get what u would
wouldn't you
equal,
just
it would
put
equal
positive
12.
12 into x squared next?
So when you're finding the answer for what the x-axis would be, that's when you flip the sign. But if you're just doing when you're just factoring it out to -12 and -6, you keep the signs the same.
Shoot. Okay.
And then that creates two polynomials that you can factor from there, and then find your answers. That would be -3, -4, and
Right.
-4, +3, and
X,
-3, +2.
x positive 3. And then you said, what were the other two numbers?
-3 and +2.
That's right. All right. So our zeros would be 4, -3, 3, and -2. Where's the answers? That's not the answers. That's not the answers. That's not the answers. There's the answers.
Yes.
3m2. What the heck is 3m2?
Where was m?
I don't know why that 3m2 is there. This all makes sense. This is what we got. But why the 3m2?
What does m even mean? Why?
Why is there even that? I don't know.
Maybe that's if you solved it a different way.
Oh, possibly.
I mean, maybe if there's two ways to solve it, and that's the second answer for it. I don't know.
Maybe they just replaced u for m. I don't know. Maybe they just decided to use m on that problem.
Who knows?
Isn't there a way to do it where you substitute an m for something? I could swear there is. Because they said there's multiple ways to do these. These ones specifically where you substitute for a u.
Uh-huh.
So you could assume that they just did it the third way or whatever. I don't know. Weird to me.
Yeah, I don't know why there'd be 3 and 2 right there. Hmm. Hmm. Good question. Yeah, I honestly probably think it's just another way of notation. But I don't know. Anybody else know anything about that?
I don't.
No.
So I think we're good to continue then.
Yeah.
Yes.
Mm-hmm. Sounds good.
Super. Since this is a absolute value, we know we're going to have 2 solution sets, which is annoying, but that is the way it is. Okay. So we'll do possibility number 1, x squared minus 6 minus 5x of 0.
You could also just replace that, like switch it around and just do x squared minus 5x minus 6, and that turns into f factors out well.
What did you say?
X minus
Actually, I
6.
don't think that's what I want.
X minus 6 and
X
x
squared
plus 1.
minus 5x minus 6. Then it's easier to factor.
Yep.
Sorry, I didn't catch that. Can you repeat that again?
So just switch the 5. So it'd be x squared minus 5x minus 6.
X squared minus 5x plus 6. Okay. Minus 5x plus 6. Like that.
Minus
I see.
6.
Minus 6.
Minus 6. Minus 6. Duh. So that's possibility number 1.
You get negative 1 and, or negative 6 and positive 1. For your
Negative 6.
2
Yeah.
factoring things.
X minus 6 and x plus 1.
Mm-hmm.
I think that's that. Yes.
X is 6 and negative 1. And then what's the other way? Do we just
I think we have to do what I was doing before, where it doesn't factor so nicely, and do it that way. X squared minus. Wait, what did I say?
You just said x squared 6 minus 5x, which is the same thing.
X plus 1. Yeah. So it's pretty easy because you just swap the signs around for this. All this. So for this possibility, just swap these 2 signs around from here to get your other positive or negative outcome from the absolute value. So we have a 6, negative 1, negative 6, and positive 1. And that is just a 6 and 1. Interesting. Oh, duh. Because the
there's
absolute
no
value.
negatives in
The absolute value.
yeah.
That's right. So that's what that is. That's what that is.
So the next
Okay.
one, it's not as pretty.
Mm-hmm.
No kidding.
We should quadratic formula, which I may or may not have seen in the answers. So it'd be 4x plus 14x squared, or x to the fourth, sorry, plus 14x squared plus 45. And
Yeah,
then we
because
quadratic formula that out.
x to the fourth, you said? Yeah.
Yeah.
Plus 14x squared plus 45 equals to 0.
Can't we just factor that out?
Let me just check.
We might be able to.
Because if
Yeah,
you know, you'd have to, it'd be x squared plus some number times x squared. That'd give you your x fourth.
Yeah.
Well, I don't know if any numbers that add up.
9 and 5 add to
9 and
14 and multiply to 45.
Yep, you'd be correct. That would be correct. That is.
Plus 9.
And then, so our zeros are -5 and -9.
Do we have to
No,
do anything
'cause
else with the?
it
Do
would
we have to
be
do anything else though,
square-
since it's x squared?
Yeah, you'd have to
Yeah.
square your answers.
So it'd be. Oh, shoot.
It'd be 3i.
Square root of 5, right? It'd be square root of 5i, and of course negative, because when you do i's, they're always positive or negative. So it'd be positive negative square root of 5i. And then if you did the square root of 9, so it'd just be positive and negative 3.
That was -3i.
Yeah.
Well, let's see what they have to say. No
Wouldn't
eyes.
that just be 3i?
No eyes.
Why don't they have i's though?
Yeah, I thought it was weird.
Because 3 squared and -3 squared both equal 9. That's why.
There's no I on the 3, but
No
well, I just
eye.
equals 1, right? Doesn't positive I equal 1?
Minus
That's divided by 1.
5 and
So I don't think it matter that much, right?
I'm doing the quadratic formula on it just to see if we get the same answer.
Yeah.
Okay.
Mm-hmm.
I equal 1 though, so we'll just multiply 5 by I, it equals 5 anyway.
Wait, what are the answers that it gives us?
Plus or minus square root of 5 and plus or minus 3.
Whoa. Because it works miraculously well if you use the quadratic formula and the answers come out to -5 and -10.
Weird. Yeah, because this is what they claim. She claims in her answer key.
Oh, we have it written wrong. X4 and then it's -14x.
That's why. Whoops. Sorry about that.
I wrote it wrong as well. Wait, no.
Yeah, because I was like, man, that works out perfectly. Because in this
Wait. But in the actual thing, it says plus 14. What's her answer key again? Show the answer key. She wrote it wrong. The problem we're supposed to do is plus 14x, but she wrote it as negative 14x.
Ew.
She actually wrote it wrong.
Busted.
Because the problem we're supposed to do is plus 14x, but she did minus 14x.
So
So I think we're right with the eyes, aren't we? Well, I don't know.
well,
Let me see. What's the? Yeah, that's right. Let me see.
well, okay. So if you do the quadratic formula,
Either way, you're still getting the same thing, whether it's plus 14 or minus 14, right?
No, because if it was minus 14, you'd have. Well,
It'd just be negative 5 and positive 9, or negative 5 and negative 9, so it wouldn't change anything.
right.
Because then you'd still have the plus or minus anyway.
square root of 16 is 4, right?
Yeah.
Yes.
So yeah, if you were to do the quadratic formula, I don't know why I'm like insisting this so much, but you would just get negative 14 plus or minus the square root of 16 all over 2.
X squared plus 5 equals to 0. We'll do that real quick. Everything to 0. And x squared plus 9 goes to 0. This one, x squared equals negative 5. Equals negative 5. And this one squared, x
It's
squared
still going to
equals,
be plus or minus 3, though. You have to square root both sides.
yeah, equals negative 9. And
For
x
negative number, you have to throw the I in there.
x equals the square root option v of negative 5. And this equals x equals square root of negative 9. Let's see. Tail.
I think she just forgot the I. That's all.
Let me just check real quick.
Because, yeah, it would be plus or minus I square root 5.
Yeah, probably, honestly. It's not 6.5. And this one would come out to be negative 3.
Yeah.
No, because you have to do an I with the 3 in order to.
Oh, right. Negative 3i. Look good, everybody? Does that look good?
Well, so I represents negative 1.
Yes. Oh, so that'd be that.
There you go.
That's right. That's right. That's right. That's right. You're right. Right. Okay.
So
That looks good.
in front of the radical, correct?
You want to what?
That's just why we throw it in front of the radical, so the negative is not in the radical.
Yes, pulling it out.
Right.
Yeah.
Just making sure. Yeah.
Last problem. Find a polynomial with real coefficients and has zeros of 2 and 1 minus I. You should use the concept of conjugate pairs from the resources. Yikes.
Yep.
I don't even remember the conjugate pairs, so I don't know if I'm going to be much help.
Let's go look. Resources.
Wow, it just takes you to My Math Lab, e-text and videos.
Yeah. Where is conjugate pairs? Well, Yes, I can groups. That's not it. What the?
The conjugate pairs isn't in the PowerPoint.
What?
What? Am I the only one that saw the PowerPoint?
I looked at it, but I didn't really understand it too much.
No, if it's not Khan Academy, I don't understand it.
Well, let's do that right now.
Are we gonna watch Khan Academy conjugates?
Yeah, might as well. Honestly.
I just want to know what real life application we're doing all this for anyway.
Especially if you're going to become a dentist like myself.
I know.
It's for times that
You
we're
don't
starting
even-
in pre-calc online, so we need to know how to do this stuff.
Yeah.
Engineering, yeah, definitely. You should probably learn some of this stuff. No.
Conjugate acid base pairs. What?
What? That's chemistry.
That's chemistry. No way.
Freak, man.
I wouldn't put acid base. It's just conjugate pairs.
Why did I put that? Probably.
It auto corrected you to that.
And it still wants to do that. Complex conjugates?
Gosh. Okay.
Yeah, that says pre-cal, so I go with complex conjugates.
It says imagining complex numbers, so it's probably
8 minutes long.
That's long.
We're going for it. We're committed.
All right, let's do it.
Are we that committed though? Just kidding.
I don't hear Sal speaking.
I'm glad you know his name by heart. Sal, where's my Sal?
He has such a soothing voice. I don't know.
Do we just have to plug the numbers into that formula? Because that looks nice.
So far we're making some circles.
Come on, Sal.
I hope that Sister has for the TA. Like, I hope they watch this and find this funny that we're watching the Khan Academy version. Wait, can you pause it so we can like kind of follow along with what's the actual problem?
1 plus 2i would equal z.
Okay, so
I don't know why. I just remember numbers. Oh, I didn't write that. Okay. Wait, 1 minus I and 2. 2 would equal a. And 1 minus I would equal b. So z equals 2 plus 1 minus I. And they say we bring the imaginary value over to z. Is that what they said?
Something like that.
I'm not even sure. Oh, it's just to find b if you have the imaginary and the z,
Mm-hmm.
and then the other way around, or something like that. I don't know.
I was watching. See, keep watching.
I kind of wish that the teacher would do like a early week, like just teach you how to do stuff lesson.
It'd be nice. Y'all can hear it, right? Can you guys hear the video?
No.
On. True.
If I listen really hard, I can.
I can imagine Sal's voice.
Hmm. Oh, I
I
can
mean,
put close.
I can follow along, like, oh, that works, yeah.
We'll do that.
Clearly.
Oh, it's the graph. Is it? Didn't we learn something about graphing?
Yeah, that was gonna
What
take.
the?
Whoa. What? What?
Well, that escalated quickly.
Gosh, that's what I'm saying.
Whoa. It's all so colorful. I don't. But like,
Sal lied. Just kidding.
I don't understand what.
Hmm.
What,
I
you
don't
guys
know.
didn't learn everything you need to know from that picture right there?
I don't know how we're supposed to do this though. That makes no sense to me. I mean,
we like pretend like we did and call it a day.
she would watch the video. She would know. You just said it. You admitted it.
You should have like done signals or something.
Like what?
I don't know, blink twice.
Find
Can
out
we try and can we try and put this into a calculator online and see if it has a step by step and we can learn it that way?
Can you type in the find a polynomial part with the numbers?
I could try. I mean, let's try.
Google that.
Well, I'm thinking if we can at least see like how it's done, it will probably help us a little bit more than what Sal gave us
totally.
there.
Oh, look, there's the video that we're supposed to get right there. And it's one of two. There's two videos.
Oh,
And they're both 10 minutes long.
Yeah, right, yeah.
Good night.
yeah.
I like. I mean, just I would click on the link underneath the study.com. It's the fourth down.
Yeah.
And just see what it says.
Oh, there's videos. Oh, turning zeros into functions. A typical part of an algebra course is learning how to factor and find solutions of polynomial functions, such as quadratic equations.
Typically. Nice.
You often also learn how to factor and find solutions of polynomial blah 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 blah.
Does it say process steps?
Yeah. Okay, we'll use the following steps to write a polynomial function from its given zeros. Convert the zeros.
Sorry, the problem's online. It's 2 is one of them, and then 1 plus y or 1
minus I.
1 minus I. So then don't we just put those in for the zeros and then factor it out? So it'd be x minus 2 times x minus 1 minus I.
That looks like it could be. So it'd be x minus 2 parentheses. And then we also have x minus 1i. X minus parentheses 1 minus I.
Yeah.
Okay.
Then we just factor it out, right?
Yeah, this is what it looks like. Let's factor it. So we would have x squared plus
Minus 2x. Minus 1 minus I. Times x.
1 minus ix, yeah.
Well, with a parentheses around it and then x.
Wait, what?
That'd be x minus ix.
X minus
If you
ix.
factor it out. Yeah.
Ix. And then wherever the parentheses go, did you say?
It would just be x minus ix.
Okay.
There wouldn't be any parentheses if you just factor it out.
Oh, right. Okay. That looks like it looks like it's to combine the like terms. Is there any like terms? Yes, there's one right there, and there's one right there.
X minus 3x.
X squared minus
3x minus ix minus 2 minus 2i. Does that sound right?
yeah.
We could replace the I with -1 and multiply that by 2. Since we know what the value of I is.
That'd
We
be
just switch the sign, that would be plus 2.
right. Switch the sign to 2, and -2 plus 2 is just 0.
Yeah.
That just makes it that.
And that'd be x squared plus or minus 2x.
X squared minus 2x.
Yeah, because the ix would be positive x, and you add 1x
Oh, right.
to -3, that makes 2x. It'd be x squared minus 2x. It's what you'd end up if you simplified all the way.
What the heck?
And that is not what I had.
Whoa, where did she get that answer from?
Let's try to work this out.
How about we ask her how to work it out for us and send us like a screenshot or a PDF?
Seriously.
Well, it looks like we
or a video of her doing it.
x minus 1 minus I. We
Times
just
x minus 1 plus 1 I.
But why
X
is that
minus
second 1 plus I?
1 plus I.
One.
Where did that come from?
Where did this come from?
Yeah.
That's a good question.
They're imaginary. That's my question.
I mean, so we had the idea right.
Yeah, we just don't know where this particular part of it came from. And I guess if you, that makes sense. If you expanded and factored it out, that makes
I mean,
sense.
is it because when you have an I, it's a negative square root, and when you have a square root, you have
Oh,
to have a plus and a minus?
that could be.
That's what I was thinking. So
whenever there's an I, make sure there's a plus I in addition.
Oh yeah, because when you have a square root, you have two answers, as I is a positive I and a negative I.
That makes sense. And then if you were to factor it out, it would be about this. That makes sense.
Yeah. Mm-hmm.
Makes sense. Well, anything else that we need to talk about?
Nope. I think
Nope.
we're good.
I understand everything.
Same.
All right. Then you can teach us next time. I'm just kidding. All right.
Have
We
to
can.
watch more Sal.
All right.
Yeah, we'll see you guys.
All right.
All right. We'll see ya.
Bye.
Bye.